All right, geometry, it is time for sections 2.7 and 2.8, and this is Mr. Zabo. So, for section 2.7 in particular, we're dealing with the transitive property and substitution properties. And these are a couple of theorems with the transitive property. They're similar, but there are some small differences. So, if we take a look for the transitive property, it states that if an angles or segments are congruent. So if angle A is congruent to angle B and angle B is congruent to angle C, we can skip the middleman. B and B, these kind of match up, and we can go straight from A to C. This is the chain rule, the logic rule we learned in chapter 1. And the same thing happens with segments. If segment AB is congruent to segment DE and segment DE is congruent to segment XZ, we can skip the middleman, chain these together. This transitive property can happen over a period of however many chains or however many times that we can apply this transitive property. It's slightly different than the substitution property because it can be extended over, so segment A or angle A is congruent to angle B is congruent to angle C is congruent to angle D is congruent to angle E, well then angle A is congruent to angle E. Okay, so we can apply it that far, we can even further. Substitution is not going to be applied that far. In these first two examples, angle A and B and angle C, then the segments, in these two examples, we technically could have used substitution in there as well. Okay, but that is an example of the transitive property. Substitution is the stuff that we've been using in algebra, and that's going to happen more when it's not all congruent statements. Okay, so we have a complementary statement. This is just an example. If these angles are complementary and I know angle 2 is congruent to angle 3, well, I can now substitute angle 3 in for angle 2 in my complementary statement. So typically transitive is going to happen through a series of congruent statements. And the substitution property is going to apply through one congruent statement and then maybe a secondary statement with complementary or supplementary. And there's going to be a few other ideas that we look at as well. So in section 2.8, we start talking about opposite rays, and now we will formally identify and define vertical angles and talk about a vertical angle theorem. So first, opposite rays. These are two collinear rays. They have to share an endpoint and extend in opposite directions. So they will always form a line. In this diagram, our two rays that we would then name are ray QR is this ray here. I could say ray QR and ray QP are opposite rays. Notice I had Q as that common endpoint, and they go in extend in exact opposite directions to form a line. Those are opposite rays. It has to have both of those two criteria in place in order for them to be defined as opposite rays. It can't be just sharing an endpoint, otherwise they're just making any angle, not a straight angle. Okay? Now, to formally define our vertical angles, it's two angles in which the sides of one are opposite rays to the sides of the other. Okay. And so in our diagram here, the sides of these angles, opposite rays, essentially intersecting lines. Okay. And the vertical angle theorem states that if two angles are vertical angles, then they are congruent. Now, we can assume straight angles from a diagram, therefore we can assume vertical angles from a diagram. But we have to first state that we have vertical angles before we can apply this theorem saying that they are congruent. Okay. And just to make sure that we're aware, in this case, angles 1 and 2 are vertical angles. That is not usually missed. Those are congruent, but so are angles 3 and 4, even though they're not top and bottom. They are still vertical angles. They are opposite angles formed at intersecting lines. So angle 3 is congruent to angle 4 as well. And we would state in our proof as our reason, vert angles imply congruent. All right, so now let's take a look at some of our proofs that we're going to use based on the theorems that we learned, transitive substitution, and our vertical angles. So in this case, we have these three given segments. If we mark our segments congruent up here, we have segment TP congruent to segment QR. Don't just assume that TP and QR are in the same location. They are in different locations here on this diagram, so be very aware of that. Okay, we have segment TW, so I will address that this way. I'll say TW is congruent to segment QW. That's this way. And segment PW, I'll say is this, is congruent to segment KW. That's this. We're trying to prove that Q is the midpoint of segment KR. Okay. Well, kind of draw my little diagram up here. If I know that TW is congruent to QW and that PW is congruent to KW, I can conclude that this segment and this segment will be congruent using the subtraction property. So these two pieces tell me that segment PT is going to be congruent to segment KQ. That's helpful because now that I also know this segment up here with this segment down here, okay, I know that by the transitive property that segment KQ must be congruent to segment QR, and therefore I know I have a midpoint. So go ahead and there's the outline up here. See if you can draw that up in 6 steps in the statements and reasons at the bottom. Press pause and try that. All right, so writing up my 2-column proof, I have my 2 given statements. Now, I didn't write all 3 given statements first. I started with the 2 that I did. This is step 1, this is step 2, this was my step 3, step 4 together. That allowed me to conclude 5, 5 allowed me to conclude 6. So my givens, then my subtraction, and over here on the right, I just kind of put what was my subtraction. That's not mandatory, that just kind of helps me make my decisions as to what property I'm using. And then for my transitive property, again, since it was a string of congruent statements, that's typically when you're going to use transitive. If it was something other than only congruent statements, that's when you might use substitution. That does not mean substitution would not work here. It's just typical that you're going to use transitive in a situation like this. Okay. All right, moving on. See if you can try this one on your own. Pause and try this one. Takes 1 or 2 minutes. You will need to make an assumption from the diagram on doing this proof. Here is that assumption. All right, so once we able to state that my angle MAR is a straight angle, and remember, we need to name the angle with 3 letters. We can't say that it's a line. Lines aren't straight angle, they are, but you got to make sure you name the angle. Angle MAR is a straight angle. Then you can state that those 2 angles, angles 2 and 3, are supplementary because straight angles imply supplementary. A state are given, and then our final. This is substitution because we're substituting one congruent angle in for the other inside a supplementary statement. And we have one more proof that I want you guys to try. See what you can do on this last proof. All right, and so on this one, we have our given. We do, and this is the statement that gets missed a lot. We do want to make sure that we state that we have vertical angles. before we can state that those two angles are congruent because they're vertical angles. So vertical angles can be assumed from the diagram. We'll state that 1 and 2 are vertical angles, assumed from the diagram. Now they're congruent because vertical angles are congruent. I used transitive property because it was just a string of congruent statements. If you used substitution here, it's not wrong. Okay? But it's only wrong for substitution if we would have had, say, 3 or 4 different congruent statements that we were stringing together. That can't be substitution. That's going to definitely be our transitive property.